go live on YouTube. Should be fun. Also, MADI, there's someone coming in with the name of the university.
Oh, yes, it's me.
Oh, that's you. Okay.
No, I guess so. I mean, I don't know because I've registered. No, maybe not. Maybe not. It could be the classroom instead.
Maybe.
Maybe, yeah. Just let me double check. Because on the event right there's another link to the YouTube, correct?
Yes. Yes.
Perfect.
Yeah. I'm super excited. I like that. I miss that buzz. It's MADI.
Davide, yeah, there's MADI there.
Hello everyone, let me just set up the projection and in a couple of minutes we should be online.
Okay, so you are in the classroom with all the students?
Yeah, I was thinking about projecting so you can see all the classroom.
Perfect, so we'll make
a minute.
Okay. All right. I miss that buzz where when you come into like to set a presentation and everybody is sitting down and there's like a buzz right before, almost like a concert where we're all engulfed into this like music. So I'm excited. So I'm streaming live our talk even though they can't see us. Anyway. Maddie, when you're ready, let me know so I can start the session. Hopefully some people will be coming in on YouTube.
Yeah.
Right.
I think if you want to start, we can
start.
Should I
start?
Yeah, because if they are watching on YouTube, you can start and then they will connect.
Okay, there's some people that are still sort of logging in, so I'm admitting them, but I think you guys can see them on your side, so. Okay. I guess we will start, and let's see. Right, so hello everybody. Let's see. I can't see my face on the thingamajig. Doesn't matter. So welcome to our second session of the By Design series talk or talk series, part of our new MSc in Computational Architecture program. We are super excited about that. We are joined by guests from MADI, our sister program at IUAV University in Venice. MADI is a master's degree in digital architecture that has been running for 10 years. It is directed by Fabio Daniano. Fabio is also collaborating with us as an associate professor from the Center of Fine Print Research in the Faculty of Arts, Creative Industry, and Education. They are collaborating with the MSc, and we will be using their incredible digital fabrication lab. It's super exciting and super cool. Today's session, Form by Design, will be moderated by Dr. Eleonora Nicoletti, a lecturer in architecture here in APE. Her research focuses on design of solar architectural skins and their communicative potential for public space as well as energy generation. She teaches computation design in the BSc Product Design and MArch programs in our department and is part of the new MSc in Computational Architecture program. We are also excited to have talks from Arturo Tedeschi and Matteo Silverio from Venice. Arturo is an Italian architect and computational designer, internationally renowned for his sculptural and visionary approach combined with research and advanced design methods, materials, and fabrication technologies. His use of digital technology blurs the line between disciplines and emphasizes the semantic and emotional values of objects which engage all the senses. Matteo is a Venetian architect and a research expert in computational design and digital fabrication. With his office Silverio, he is involved in multidisciplinary contamination projects that span from architecture, design, and art. He supports teaching activities at the IUAV University at Venice, the European Institute of Design, and the Academy of Fine Arts in Rovereto. So we have a full Italian panel, including our own Eleonora. who will take over from me now.
Thanks, Mirat, for this very thorough and detailed introduction. It's really great to be part of this. And thank you to our speakers who joined us today. I will invite the first speaker now, Arturo. It's a pleasure to have you here. Thank you for joining us. I think anybody who has even just tried to approach algorithmic design will have come across your work, including the books, your wonderful books about algorithmic design and Grasshopper 3D. I really look forward to seeing your work now. And if anybody from the audience who might have questions can quite easily enter them in the chat, and we'll have time for discussion after presentations by our guests. Thank you, Arturo.
Great. Thank you so much for the invitation, first of all, and for your nice introduction. First of all, I hope that you can hear my voice clearly and also the screen. So I'm going to share a presentation that actually I'm set it up as a kind of open conversation with a set of, in a way, a set of questions to our audience. So it won't be totally focused on my work. So I mean, I actually prepared it in order to open possible question and to start a discussion with you guys and with our speakers. So let me just share the screen. Okay. Okay, yeah, so as mentioned, and thank you again, Eleonora, my name is Arturo Tedeschi. I'm an architect and computational designer based in Milano, Italy, and I'm the founder and creative director of my own studio here that since 2010 provides computational design services for leading companies, architects, artists, and so on. In a way, the distinctive feature of my work is definitely the variety of materials, technologies, typologies, industries we work for over the last 10 years. But I can, in a way, I can clearly recognize a kind of, common thread that is in a way a kind of undefined research of beauty. For me, one of the most important things is like it's a constant research of beauty, whatever it is. Beauty is a kind of ghost word. When you try to define it, it like goes away. It's very difficult, but I mean, my very aim is trying to use all the possible materials, technologies, in order to find my idea of beauty. So it's a kind of endless research that led me to different projects like furniture, where for example, this one, which is called Sistema Fessura. Again, I don't want to talk about the specific projects, but I like to say and to show, again, the variety of technologies, materials, and languages that I use. And I want to say something, since we have probably a lot of students that are like watching us in this moment, is I always like to not be trapped in problem solving in my life as a designer, but I always try to put the work on a level where you can have a kind of discussion, and it's always important to me to have a kind of philosophical approach on every project. In this case, you can see a variety of freeform geometry made by using Corian with a milling machine technology, or we collaborated with other architects for creating, for example, the stadium skin using steel and, again, computational design tools and methodologies. Or we work a lot in footwear. This is a collaboration with the British designer Ross Lovegrove, and this is a 3D printed object. So again, different ways for achieving this ideal trajectory towards beauty. Interior design, installations, automotive. This is something, automotive is one of my favorite, I don't know to say topics, automotive and transportation, because it's a field that is constantly changing, and we will have a great update and upgrade of the idea that we have of cars in the closer future. This is a recent, actually this is a project developed 3 years ago, but this car, the city car, is out since May 2nd, and we worked in several parts of the car's body. Again, installation or jewelry, recent project, a collaboration with a company in Venice, Maison 203, and we created, again, jewelry and objects using computational design tools without any kind of fetishism, but again, trying to put the beauty, the female beauty as a part of the process in this case. Or furniture, but always trying to push the boundaries in a way. For example, this is a chair, this is called the oyster chair, where the whole object was designed using virtual reality, and to me, the final output really looks like a primitive object, because we use our hands in a virtual way, in a new way, and also relying on a robotic arm in order to actually fabricate the product. And also, we also try to create a new kind of typologies in terms of architecture. This is a project which is called the Cloud Bridge, that was born as a pure concept, now is under development. We are collaborating with engineers and specialists in complex structures in order to make these things come true. We have a client for that. Again, it's a very complicated and complex project to put into reality. But again, I like to avoid the problem-solving approach in order to keep this kind of level of philosophical speculation, if you like, on every project. As I was saying, constant research of beauty, but of course, algorithmic thinking is, is one of the characteristics of my research and work. I deeply believe that our minds are powerful and our hands are limited. Algorithmic design allows us to overcome the limitations of the manual ability of, or also the traditional software, trying to reach a level of complexity which is beyond, the manual ability again, and which belongs to the mind territory in a way. So algorithmic thinking is absolutely the use of algorithms. I always like to say that the word algorithm is not connected with the computer, but is a word that is directly connected with the way human beings think and how we split a complex problem into a simple task in order to achieve something. I also define myself as an independent researcher. Over the years, I did collaborate with universities, academic institutions, but since the beginning, I led a personal research which converged, as Eleonora mentioned before, into three publications. The most recent is AAD, Algorithms Aided Design, which is considered one of the reference books on the topic, and that's really an incredible result to me, as it was written, and published without any kind of external support. I really made it. Sorry if I used the garage metaphor, but I didn't have a garage at that time. But I really wrote it in my small room, and it was actually a kind of philanthropic work, and I'm really proud of it. I'm really happy when I see the book all over the world and shared online, and it's really I still don't believe the result that he achieved. And every day people ask me, when are you going to write the next one? And I really would like to find the time to do it, actually. As I said before, my work is characterized by a kind of transversal approach, as you see, different industries, architecture, interior, installations, and so the word multidisciplinarity in a way pops up. But to me, this word, and I don't know to say crossing disciplines, which is again something that emerged when you just see my portfolio. I mean, it doesn't just mean jumping from a project to another, from the small scale to the big one. It's not, let's say, it's not even the romantic Italian, you know, approach from the spoon to the city expressed by Ernesto Nathan Rogers, for example. And not even the idea of the designer as a demiurge, as a creator able to shape, you know, desires and needs of everyone, that can create a house or a chair or whatever. To me, the expression crossing disciplines reminds me to a scene from the movie The Matrix, when you know, Keanu Reeves is speaking with a young boy who teaches to the protagonist how to bend a spoon with the power of mind. And the young guy say, don't try to bend the spoon because that's impossible. It's not the spoon that bends, but actually it's yourself that can do this kind of bending, you know? So I always try to imagine this kind of metaphor and this message when I jump from a project to another. And I never identified myself in manifestos or design philosophies in a way. And actually, I never fell in love with a process or with a design feature, and I try to scale up or down something applying to a car or a product or a building. I always try, again, to bend myself in order to understand the specific client, the specific industry and context. And over the years, I know that it sounds probably fake, but I have a kind of set, I call it the set of dualities or dichotomies that I have in my office. Every time I face a new project, I always try to answer these questions, a set of questions or duality, if you like. And that's why I said at the beginning, I'd like to imagine this as a kind of open discussion also for our audience. So the first one is like continuity and disruption. So if you work in computational design, you know, being disruptive is a kind of, seems to be the only possible direction. So in front of an image like this, of course, we all have a kind of wow effect. Super interesting, intricate object made by robotic. It looks like a new species of, you know, objects. Something like never seen before. And it seems like the right theoretical direction. It looks like the things to do if you are a computational designer who works in 2021. But if I open a fashion magazine, or if I open the Zine or other, you know, magazine, or in general architecture or design communication, I also see something like that, you know? This is a recent show on the left side by Louis Vuitton, designed by Virgil Abloh, that actually he's an architect. And you can see those clothes that look like buildings, you know, and it looks disruptive, but actually we have a total continuity with a very famous masked ball that happened in New York, I think in 1931, where the architects, they were disguised by their own famous building, most famous buildings. So, I mean, it's always about this kind of relationship between continuity and disruption. And I always try to think when I start a new collaboration, a new project, if I have to go in one direction or on the other, there is not just one answer to me. It also happens in architecture. If you just to take a look to these projects by Norman Foster for Apple, for example, they are in total continuity. We can say that they are a kind of homage to Russian buildings from the 60s. But being disruptive, for example, can be a quality when we conceive a new breed of objects, again, for example, maybe totally integrated with nature, that use natural materials and maybe built with the latest manufacture technologies. I showed you before the Cloud Bridge project. Maybe in this case, being disruptive was the right thing to do. I like to show you and talk about those again, dichotomies, because sometimes when we start doing a project, and mainly I say that from a computational designer perspective, we just open the latest 3D modeling tool or algorithm and etc. We don't think about the possibility sometimes to use advanced tools in order to create something which is in total continuity with the past. And from my perspective, it's always important to create this kind of again, to put the thing to this level of discussion and to be speculative in a way, to have a kind of philosophical speculation when you start working on something new. Or this kind of duality, which is super important to be storytelling versus functionality. I recently stumbled into this project by Nendo that was overpublished on design magazines. And I realized the power of the storytelling and the message behind it, which is in a way more important than the functionality itself. You know, creating a 3D kit to facilitate shipping of soccer balls for impoverished communities, for example, wouldn't have, for example, even an air pump for inflating a ball. It's very interesting, the idea of creating a story more than a product, for example. And sometimes I think in the real market, the story is the real function. We never have to forget that. And also, if we go beyond a capitalistic world, sometimes the story is the real function. And when you deal with algorithms, you may forget that. Sometimes you forget there is something which goes really beyond the idea of using tools and technologies in order to create the perfect product. Let's see, for example, in a society based on data and digital technology, sometimes we take technologies for granted. Sometimes functionality is a given value, and the designer is invited to meet immaterial and not measurable needs. So coming back to this image, okay, probably this is perfect. It perfectly works, but there is no storytelling behind this mask. And so probably is not the right answer. Or let's think about, designing a lamp. This is a product from Dyson that works with, the light cycle. It's a super pure object. It's a functional. It uses the right material, nice mechanical lifting combination of things. But maybe if you live in a city and you live alone and you come back home after 12 years of work, probably you want to turn on the light and you want to see this monkey lamp handing a bulb on its hand. So, sometimes we should go beyond the idea of strict functional approach. And so maybe this one is the right answer. And this is a three-dimensional product in a way. It doesn't mean that you can do it without any computational tool, or it's more simple to design it compared to this one. And I want to show you something. Let's imagine that we are all photographers. On the left side, you can see a beautiful photo shoot of the Golden Gate Bridge in San Francisco. On the right side, we have more or less the same bridge. Probably it's not the same bridge, but similar. They are both nice photographs, but the right one tells a story. You can see the sun, you can see that car coming there. So with the same tools, you can do a good job, but one of those images tells a story. The other one doesn't do anything in a way. It's just a beautiful picture. So sometimes we have to try to reach this level of richness or complexity. Other questions. We love customization, computational designers, and we love to create tools or methodologies or devices or whatever, portal, everything that allows clients or other people to adjust. We create parametric tools sometimes, but is it the only thing that we can do? People want customization, or in the future we are going toward a world of unique pieces. So this is an open question. It's not that obvious, because so far the market doesn't say we want customization, but probably the opposite, because there is a market. And again, I'm not talking only about a capitalistic world. I mean, the reaction to what people want today. I always say something like, we are living in the age of Deliveroo. You know, the age where people want something and they want it right now. I want a pizza. I have an app and I get a pizza in a couple of minutes. Or if you live in a city. So probably having a unique piece, having something which is personal, probably it's a kind of trend of the future. But anyway, it's an open question. Modular versus additive. Okay. Every time you open a design magazine, you read every day something like the first 3D printed house. I don't know what's the first 3D printed house, because every time I open a magazine, I read that. And so, okay, 3D printing is the future. Okay, but we are working on a project in this period, is a building, is a high-rise building in Switzerland, and they are like using a kind of volumetric construction, so a modular construction. Modular in a new way. We are not talking about the 70s technology, but a new kind of modularity. So again, is additive manufacturing the only possible way for the future? Is modularity should we take it into consideration? Or milling? For example, I can see that in the industry, there is a kind of taboo for milling, because it looks like more expensive. You need robots or complex machinery. But if you think that a robot is like guided by a software, so you can easily change a piece of software and you can create new things. I mean, there are open questions still about that. Or this is another thing that I like to show every time, is like this kind of duality between minimalism and maximalism. This is a project by Nagami. Nagami is a company in Spain. I always say, when I see this project, I see it's a kind of Rosetta Stone of our century in a way, because it's a robotic chair, is cross-section is created using, static forces. I mean, it's a minimalistic in a smart way. But I was like watching a Netflix series a couple of months ago, and the cover image is about another chair, which is designed by an Italian designer, Fabio Novembre, that you probably know, the so-called Nemo chair, which looks like a mask, like a face in a way. And why I like to compare the two things, because sometimes, and in a way we are talking about minimalism for the Nagami chair and maximalism in terms of design language for the Nemo chair. I think that sometimes we, as designers, we design for designers. I mean, probably Arturo or Matteo or the people in the audience will like this, because we know the message behind this product. We know the complexity. We understand the kind of hidden message. But people will find a connection with this kind of product, probably. A product where the message is simple, even if, it's based on like this kind of maximalism. It's a chair that doesn't look like a chair. So again, to me, the answer is trying to do something in between. If my approach, I try to do it, but it's not easy to do it. I always try to do a kind of balance, and I always try to design for people, not design for designers, even if I think that this object is a masterpiece. But I can also understand that sometimes maximalism is in a way, or finding a balance between them is very important to do. Physical and virtual. I mean, we over the last year and a half, we are in a virtual event in this moment. But what will happen in the future? I really like the approach of Prada that made two very significant to me fashion show. The first one was in 2020, where the models were in
Arturo,
yeah.
Sorry for interrupting.
Yeah,
it's
please.
Super interesting. We should also invite Matteo soon.
Yeah.
Otherwise, we run out of time.
Okay, so I jump very fast. Thank you so much. I like the idea that Prada, in the first fashion show 1 year ago, they used models in an empty room with just cameras, and in the next one they use something similar, no audience, but they call it the possible feelings, in order to trying to transmit the idea of feelings, this kind of fur-like, but like walls, in order to communicate a kind of feelings from a virtual space. So in a way, it reminds to our need to stay together, to feel something, and probably we will come back to normality, where we will probably get bored by virtuality, 100% virtuality. Do I have 1 minute still, or I'm run out of time?
1 minute to conclude.
1 minute, the very last one, and thanks to you for the reminder. And let me jump on just this one, big scale versus small scale. I worked in different, scale and industries. Something important for designers, and sometimes we think that the small scale is more simple than the big ones, but it's important to remember that a building has an impact on a limited amount of space and amount of people. If you consider it, a building like this, which is amazing, it has a power of communication because we are talking about it, but it is in the Azerbaijan, in a specific place, influencing a small amount of people. A product can affect the human posture and the habits all over the world. So a product can be very dangerous, or, in the opposite, can change the life of people in a way. So even if something is smaller, it doesn't mean it's more simple to be designed and fabricated. Thank you so much. Sorry if I ran out of time. I mean, thank you so much. I hope you enjoy it.
Thank you, Arturo. This is really interesting. I really hope there are many of our students following, either here or on YouTube,
right,
including our product design students. Just a reminder to the audience, you can start entering your questions. I will now invite our next speaker, but we will go back to the questions as soon as the presentations are over. So as they come up, please don't hesitate to enter them in the chat. Thanks again, Arturo. I would like to invite Matteo now. Matteo Silverio also is an architect, unlike Arturo, who's based in Milan. Matteo is based in Venice, a very difficult context to deal with, I think. So it would be very interesting to find out more about your work. You're also crossing disciplines, Matteo, from what I understand. So, well, I'll just leave the stage to you. And thanks for being here.
Thank you to have invited me first, and thank you, Arturo, for your lectures. And can you see my screen, just to be sure? Okay, so good afternoon, first of all. I'm really happy to be here, and I mean, my presentation will be more pragmatic, let's say, in a way. But first, let's introduce myself, okay? Okay, what do you do? Who are you, Matteo? I mean, this is not an easy answer. I have something in common with Arturo. It's hard to explain what we do because we are architect, we are designer. Honestly, someone call me artist sometimes, but I believe these tags don't really work on me, on us, because I'm not interested in a specific field. What really interests me is understanding how technologies is changing our life and how technologies can improve our work in designing and producing items. And to do so, I apply a multidisciplinary approach, often contaminating different industries. So I look at myself as a contaminator, which actually, after a world pandemic, is not the best way to introduce yourself. But yes, what I love doing is generating positive contamination, okay, between art, craft, design by using technologies. And you mentioned, Venice, you mentioned Murano. My office, I'm in Murano in this moment. And what I like to contaminating the most is glass. I work in tight contact with many Murano glass masters, and with them I promote a wide range of projects, mostly research projects, like this one with Stefano Bullo. Here, starting from Stefano's normal stained glass windows production, we have investigated how to make the glass shapeable. We run many digital simulations to find the best and most affordable grade, and we use Stefano's silk screen printing skills to color the glass, apply digitally controlled textures. Okay, and then we had a lot of fun with this project, and the project evolved until the Touch Me collection. Okay. And this is a vase out of Murano glass that can be shaped by normal user. So the owner of this object, okay, can customize its shape. It's a way of democratize glass. Even more important, this collection used waste glass. And this is important because our generation has a big challenge to tackle. Sustainability is not an option anymore, and we must change the way we use natural resources. Okay, I know it's rhetoric, but it is. And this brings me to another project I would like to briefly introduce. Okay, this project aims to reuse Murano glass waste thanks to digital fabrication tools. Because this is not really not be recycled with normal glass. This is because the chemical element used to make the colors contaminate, and in this case it's a bad contamination, the glass. Glass waste is a big economical and environmental issue for Murano glass factories. Okay, so I started implementing a way to reuse it, to reuse the waste. This blue paste is glass with cobalt, by the way, is Murano glass powder with some binder. And I'm using just a commercial Delta 3D printer, easy, okay? And this process takes place at room temperature. And on the left, you see the output from the 3D printer, and on the right, the piece after 2 hours in the oven, low temperature, okay? So even here, we are saving a lot of energy. Of course, this process can help glassmaster to reuse waste material, which was, our starting point. But this process can also be used to create shapes that cannot be made with traditional techniques. So it's a tool to go beyond tradition. It's a tool to reinvent Murano craftsmanship, okay, which is my main focus. But back on starting point of the project, okay? Before I mentioned sustainability. Our society has a huge impact to our planet, and climate change is one right? We all know. And he's introduced the SkyTide project, which it has a lot to say about how bad we are running our planet. Starting point, Venice. I guess we all know Venice. Venice is an amazing city. It's well known for its monuments, its beauty, and high tide. The high tide is part of Venice. Okay. Venice kind of floats on the surface of water, okay? And tourists love it, this idea of having water almost everywhere. Venetian a bit less, especially if the water reaches 187 centimeters during a thunderstorm. This happened almost 2 years ago. It was the 12th November 2019, the second highest tide in town. It was a kind of traumatic event for everyone. It was also the beginning of another traumatic event called pandemic. We started before with problems. By the way, last year, to commemorate this traumatic event, Caposcari University and Science Gallery promoted the Aquagranda project. The Aquagranda project, it's basically a digital archive who collects video, WhatsApp chats, images about at night. It's a tool for public consciousness. The project also has promoted short films and art pieces, all related to the high tide, but more in general, they are all related with global warming and climate change, because the high tide, the Aquagranda, has been the consequence of climate change. So at some point, Science Gallery decided to spread some landmarks within the city to advertise the project, but also to create a sort of gate to link our physical world to the digital archive, okay? And they asked me to design these 8 gates. 8 gates to be placed in important Venetian museum and institution. So, I immediately started working on that, okay? First, examining the archive, looking for visual memories like the one we've just seen, you know? Or like these ones from Murano, again. These are, shocking me also now. You see this theme. To maintain the furnace on, Glassmaster had to rise temperature till 1,400 degrees, which is the maximum level, okay? Because the water was too close to the combustion chamber. So they were about to explode, okay? The material you can find visiting the Aquagranda website is quite impressive. It's a lot of stuff that seems coming from a disaster movie like The Day After Tomorrow, really. But apart from that, during this research, okay, I found another kind of material. This one, data, lot of data from city sensors. And this was interesting because numbers are number. And look at this slide. For sure, it doesn't evoke strong emotions like the video we just seen, no? But they are telling the very same story. So I was in front of 2 completely different that were talking about the very same event. On the one hand, okay, people and all the emotional side, while on the other hand, okay, a huge amount of number recorded by sensors. I thought, okay, can we mix them? Can we make a bridge between data and emotion? And while I was trying to answer this question, I also started thinking about myself and my experience, because I live in Venice and I live through the Aquagranda. And honestly, to me, the Aquagranda was not such a traumatic experience, because I live in a very high area of Venice, and the tide has not even come close to my house. Here there are 2 conversations from that night, okay, from my personal WhatsApp, from my father and my uncle. I was feeling their pain, okay? They were in danger, actually, but I was trying safe on my apartment, okay, in my apartment. So I started questioning myself, why this happened? And the answer was easy. because Venice is not flat. It's almost flat. But for a city that lives on the surface of water, having a topographical difference of more than 1 meter is a lot. And this introduced the third variable to my analysis: motion, data, topography. I wanted to better understand these things, so I got the data from the Ramses project, which is the most updated topographic surface of the cities. Is this on the slide? As you can see here, these data are just about public space. So in order to extract the whole city altimetry, I had to discretize it. This is the discretized map. I divided the city in 850 clusters. At the beginning, I wanted to divide the city in 1,600 clusters, okay? Because this year we are celebrating the birthday of Venice, which has 1,600 years old. But you will see why I then decided to use 850, just 850 clusters. So then I analyze each cluster, finding a sort of mean value, and here is represented as a grayscale gradient. White means low, black means you are kind of on top of the hill, okay? So we are talking about a 3D shape. Let's represent Venice in 3D, okay? This is an informed map of the city of Venice that highlights its altitude. And on this map, I apply the water level recorded by the sensor during the Aquagranda. And this is the result. As you can see, okay, some part of Venice were quite under the water, so like some while others, like where I live, no, they are safe and dry. But thanks to this diagram, okay, it was possible to extract the real water levels in each part of the city, and then to appreciate these different levels, I flipped the water. And I eventually decided to rescale the z-axis to better appreciate these differences. Initially, I wanted the water level to be full scale, 1 by 1. So people would measure the violence of the event with their body, so to have a little physical connection between that event. However, for many reasons, mostly safety reason, it was not possible. They didn't allow me to do it. This is, by the way, a non-uniform scale map of the Aquagranda, no? 2 sets of data together to show a catastrophic event, data visualization. Well, nice. And how to translate this diagram into something real? Because so far we are on the digital side. Well, of course, using glass. So to me, glass is my favorite material, and as I told you, to make things easier, I decided to use glass rods to represent the water height, and then I started implementing the fabrication process quickly. I used Rhino and Grasshopper to implement the workflow, okay? And since the beginning, thanks to an algorithm, I cleaned and translated all the data into geometries. And it's thanks to the algorithm that I was able to obtain the 3D map of Venice. And again, thanks to the algorithm, I extracted the water levels. The algorithm has been my most powerful and reliable partner, because thanks to it, I've controlled and organized all the workflow, especially during the fabrication part. And here is the assembly scheme generated in Grasshopper. Okay, each dot has a number and a color, make the assembly quite easy and fast. Then we also 3D printed the base. By the way, the glass has been produced manually. And we're talking about 800 meters of glass rods. For those who have never seen the production of a glass rod, here it is. Basically, the glass maker takes the glass from the furnace with a metal rod. Then, with the help of a second rod, he starts gently pulling the glass. In this video, he's producing a reticello rod. It's a special technique, okay? That is why it's also, you see, rotating the glass. For your information, these glass lines are usually 30 to 40 meter long. Okay. Well, then these 800 meters of glass rods, okay, produced in 5 different colors, became 6,800 small canes with 30 different sizes. It's a lot of material, okay. Then, with a 3D printed base done and all the glass ready, we started assembling everything, okay. Here we finished. 8 pieces. They are all the same, okay. We basically obtain a skyline of water, a skyline, the Acqua Grande skyline. And this piece is a mix of, a mix of emotionless data. However, these elements, the glass, its shape, they make the piece, at least to me, kind of touching. And also because it always changes its shape. From the front, you don't really understand its Venice. But once you get closer and you look it from the top, you see the fish. You see the fish. But also the height of the tide in Venice, the night of Acqua Grande. And you see the different violence of the water that impact to the city. And that's it.
Thank you, Matteo. Very interesting use of data from the city to inform a design. You didn't just visualize the data, you materialized it.
Yeah.
It's really interesting. So I think we can start discussion then. We have the students from MADI here, students from IUAV and Venice. Please join the discussion. Also, if any of our students from the University of the West of England, please don't be shy. I'm sure you have some questions. I do have some questions too. I've seen too much interesting work. Let's see if there are any questions also coming from our YouTube audience. First of all, I think my curiosity here is about your process and also your background. So you're both architects, both trained as architects and working in architecture, but you have expanded your expertise to other fields, to art, product design, fashion, and we've seen fashion products by Arturo. So how would you say, from your perspectives and based on your experience, that computational design augments the abilities of an architect, or how does it transform the role of the architect, and why should aspiring architects develop computational skills? Too long as a question.
Yeah, I mean, it takes a couple of hours to to answer that. I mean, Matteo, do you want to go first?
As you prefer. I mean, to me, I mean, we are talking, if you want, I can start.
Yeah. Let's do it.
Maybe we have also a kind of common idea. You mentioned architecture. Yes, we are architects, but what architect means? I mean, what is the architect? What is architecture now? And this is one, okay. Architect, nowadays, the architect is not the architect of the last century. We are a kind of hybrid animals. We are not, you know, we are designer, we are architect, okay? But we are also maybe IT developer. We are producing. I'm a lot craftsman, for example, okay? Yet I'm an architect. So this is one important point to understand that architectures and the role of architects is completely changed because society is changing. And then about computational design, to me, computational design helped me to, in a way, master complexity. Okay, the complexity is not my target, of course, but sometimes you are surrounded with it. Okay, look at the last video, Akaganda. I managed to use kind of thousands of numbers, okay, by the sensor. And thanks to an algorithm, I was able to clean all this data, okay, select all the meaningful ones, and then use it for an art piece. I mean, it's an art piece. To me, it's just science. What I've done is, okay, so this is an approach. But maybe Arturo can explain better in a different way.
No, I totally agree with you. Something that I can add from my personal perspective is I believe that for a century, maybe more, we lived this kind of split between, which is an academic split between architecture, like meant as an art, with engineers, whatever it means. I mean, engineering is not only the static part, but the research part, materiality, how to put things together, how to use the best materials and whatever. So for academic reasons, in a way, architecture and engineers, they split one from each other. I think, and I really loved I really like your question, Eleonora, because you say, what's the role of computational design in order to bridge these two things? I think because, and Matteo already gave the answer, it's because computational tools, they are kind of research platforms, because you can do whatever you want, really. You can play with data, you can connect data with sensors, with robots as an input or as an output. You have a really powerful platform, and this is a research platform. Is not sometimes people, they say, what's the difference between Rhino Grasshopper, mentioned by Matteo also during the conversation, and a BIM software? Because a BIM software, BIM, so building information modeling, is intended for making buildings. Rhino and Grasshopper are really a kind of neutral platform for doing exploration. And there is also a third component, which is culture. You cannot surf among disciplines if you don't love them, if you don't do research, if you don't read things about. I always say something that a computational designer, it's something like a music producer. It's not just a sound engineer. You can be a sound engineer in your life, so you can manage all the technical stuff. But in order to be a music producer, you need to have a culture, you need to study, you need to read, you need to be curious about a specific topic. So these three ingredients, to me, they are the answer from my perspective.
It's very interesting. I have noticed also that in your work, both of you sort of combine low-tech and high-tech solutions, and also digital and physical prototyping. So I wonder, what is the balance between the two, and when does the physical material come in? Could you have the full design process as a computational design process from start to end, maybe as an only digital design development process? How do you see this?
Matteo, let's keep the order. You first and me second.
So
we flip the order of presentations.
Matteo.
I mean, it's
Matteo is a very good example how to combine.
Yeah, that's why also. That's why.
I mean, I combine. Yeah. Usually, I mean, my process, for example, involves physical and digital since the beginning. Okay. Also because I work mostly with glass. Glass is handmade glass, which is a kind of unpredictable material. Okay. So I combine, let's say 50 and 50. Okay. The first step to me is always a digital simulation. You develop the project, you run some simulation, and then you start with the prototype. And then you see the output of this prototype. You stress the prototype, and then you check. You check the digital model and the physical. Okay, and you see the difference. And then, thanks to this comparison, okay, you can improve and inform the digital. So I usually create this sort of loop. Okay, then of course it depends on project, but I use a lot of hope. And to me, this computational design, but at least the idea of creating simulation, running simulation is essential because I work also with expensive materials. And so I must be sure that something, at least something, will be done correctly. This is to me important. And also because in this way I'm linking two worlds completely different, which is the digital one, which is super advanced sometimes, and then the traditional one, which is super low tech. This is the opposite. It's not easy, but after years, okay, I found a balance, and that's it.
I think you made a very good point in the trying to save materials in the prototyping stage. So how can we extend the digital prototyping in a way that helps us save resources? It was very interesting. And I was hearing Arturo earlier talking about virtual reality too, and in his research of beauty through design, I think that is very important because it allows us to experience the designs in an immersive way before we materialize them. So Arturo, what is your perspective on the balance between digital and physical?
Yeah, well, in general, I have to say that I know that it sounds very ambitious, finding or trying to reach beauty, but this is really not just a sentence. This is really my approach, and I always use the tools and materials in a very opportunistic way. I never fell in love with any kind of methodology, strategies, tool, material, but I really try to use them in an opportunistic way. Virtual reality, for example, I never, first of all, I always liked the idea of virtual reality, and when I was a teenager, I really loved to watch every movie that was covering that topic. In the early 90s, 95 more or less, there were a lot of movies. One of them is an Italian one. His title is Nirvana by Gabriele Salvatore. I really loved that movie, and it really influenced me when I was a teenager. I never used virtual reality as a visualization tool, but my idea when I stumbled into devices and so on, I said, I want to do something. I'd like to create something with new hands, because we are monkeys. And I like to say, well, let's try to be virtual monkeys and use the hands in a new way. And so we designed a chair, which is a simple object. And as I said before, when we came out with the oyster chair, to me it looked like the Rapa Nui sculptures. It really looked like something primitive. And so I like the idea of using technology in order to create something that looks simple and primitive in a way. So I always try, my idea for virtual reality was something like that. So poetic, if you like, or just as an artist uses new tools. But we also recently, 1 year ago, we did an exploration together with Volkswagen. We presented a project together with other designers. And we tried to use virtual reality in order to create a car in a new way with different designers working in the same time around the car. So imagine to have a virtual laboratory, where a designer is outside the car, one is inside the car, and so you can play and coordinate this work. So in that case, it was about the process, how to use virtual reality for developing a novel process for designing something. Because, and now the question is very important, because virtual and physical. I mean, if I remember, was Bézier, one of the inventor of the so-called Bézier curves. He said something that the computer can actually simulate the 80%. Sorry, I don't remember exactly the percentage, but it was saying the computer cannot render the actual shape, even if you have a super powerful software to use. So you need physicality. And I will be very, I will say something very cliche. You need the fourth dimension in order to actually understand. And so virtual reality helps you in having something like that. But really, an actual mock-up, a physical mock-up, always, it's always important. That's why, for example, when they design cars, they always create a one-to-one mock-up, because you understand, otherwise you cannot really understand the perception. And we are, as Matteo said, we are in a way animals. We need to also have a kind of direct. But we are, human beings are the only animals that they design, they draw something to anticipate the output. So, and today we don't just make drawings, but we do digital models. And it's a kind of evolution anyway.
Thank you. It's interesting to hear about the limitations that you see in this process, the digital process, but also the potential that using virtual reality as a collaborative platform and for simulation rather than representation as traditional architecture visualization tools is very interesting. I think some people from the audience might have something to say about this. Should we? Is anybody from the audience willing to intervene or ask questions to our guests, for our guests here? I do have more questions otherwise. No. I think we might be approaching the end time as well, but I think you
actually I'm interested in hearing like you, I mean, because it's also always inspiring. What I feel like weird in a way is exactly what Arturo said about the 3D printed house, which is absolutely true. I've been watching tons of new first one printed out. One, it was live. I don't know. I don't even remember when it was. And I don't remember, maybe Arturo was in the first edition of the master course 10 years ago. It was new tools. And when I started with my things 30 years ago, that was new tools. We still keep on calling them new tools, which in some ways nice because we feel like mad scientists, we feel like innovators, but I'm feeling quite oldish now, you know. It's weird. It's like if you are in a rock band, you still have to make the hard rock part and your hair growing white. And I just wanted to ask you if it's a sense feeling, because if you count the number of students that are aware of digital tools or really acquire them and stop calling them new tools, is really a small percentage, and it's not changing during the years. 10 years ago, I think 10% of the students were aware of digital tools, and maybe 2% of the architects were aware. And you should think about numbers that, you know, now it's not anymore the future. It looks like it's still the future. What's your opinion about it?
So should I start us?
Yes, please.
I mean, yeah, I agree. They are not really new tools, but within the design building, industry, they still are new. For example, computational design is not really well used. Just a small percentage of offices use computational design, or at least they have inside a research and development office cluster, that study these such tools, just not only computational design, but also digital fabrication. So they are new because they are still outside the market, I mean the real market. In university, of course, they are not new anymore. More and more students are learning these such tools and skills, but then when they go outside in the market, most of the time they will use them. I mean, this is to me why, this is my personal opinion, this is why we are still, okay, referring up these old, because that 3D printer, okay, has a kind of 30 something years, okay. It was about, FDM is about 1987. So we have the same age, more or less. So it's not that young, you know, it's not new, of course. And, but yet, most of the people don't know how to use it, don't know that it can be used.
Well, my point is that the problem is not in the adjective new, is in the word tool, because I don't think they are tool anymore. First of all, I mean, a tool is something very simple to use. As a pencil is a tool, a piece of paper, a compass. In the presentation, I said algorithmic thinking. The problem is in formal education, guys. Algorithmic tools, they are considered something like, okay, you are going to learn AutoCAD, then you are learn how to render something, and then you are going to learn how to use Grasshopper for doing basic algorithms. The problem is that if formal education will still consider digital tools like algorithmic platforms as an alternative to AutoCAD or Photoshop, because it happens to me, for example. I remember when someone called me the render guy. I never done one render in my life, but they called me render guy because I was using Rhino, or I was producing freeform images or shapes. So I guess the thing is that at school, algorithmic thinking should be a specific topic. And so the idea of new tools will evaporate, will dissolve, because again, to me, they are not just tools, they are systems, they are methodologies. It's important to use, to understand the process, and then you can use whatever tool in order to apply, even because, you know, software, they evolve, and system, they evolve. I still think that there is also a problem in terms of interfaces in general. Also, the computers are very old because they were created in this kind of skeuomorphism. Sorry, it's very difficult to say. Skeuomorphism is a word that is used to say the computer mimic the reality. So we have the desktop, we still have the save button that looks like the floppy disk. I mean, everything is designed in a very 80s, 70s way, and the new tools are still like that. We need to have a kind of evolution of interfaces, and along with a new kind of formal education and new kind of terminologies probably will lead to, Fabio, to a world where we won't talk anymore about new things. But I totally agree with you that everything is in constant evolution. So principles and methodologies are the key. And I'm sure that we are slightly moving toward a dimension where we will have new, again, interfaces, new way for computing. I mean, it's very unrealistic that we are still using like powerful processor in black boxes where we can do cloud-based computing. Of course, we have an environmental issue to solve. Having cloud-based computer is connected with a lot of environmental connection problems, but in a way, I'm sure that we are slightly moving toward some, I mean, algorithmic platforms that will be easier to use. But again, formal education is the answer for that.
I completely agree. Thank you, Arturo, and thanks, Matteo, for these thoughts. And I agree we need to bring more algorithmic thinking, more than tools, into architecture education. And I think because it's the thinking. When Matteo was saying the market is perhaps limited at the moment, and if that's true, we are still trying to educate future designers. So, well, that will be the future. Shouldn't they learn? Don't they have the right to learn about how to innovate this way? And we have a wonderful question from YouTube, from someone in the audience on YouTube. How do we ensure we use digital tools to design meaningful building geometry and elements that add value to society, rather than random geometry that simply looks interesting after our experiments? So they probably have seen some computationally designed complex forms. What do you think?
I mean,
whoever wants to go first.
I mean, we are talking about tools. Okay? So we have to define a brief. We have to define the output. Here, I read, okay, two different things. From one hand, we have meaningful building, okay? I don't know, example, energy saving facade, okay? And then on the other hand, you see something that looks interesting. So crazy facade, okay? They can be the same thing, but usually they are different things. Okay? It's a way of approaching the problem. It's not, and the tool is used by humans. So humans have to understand how to go, where to go better. We cannot ensure, I mean, that people do the right thing, because the right thing maybe doesn't exist. It's tricky. It's tricky. The thing is, the point, I guess, behind this question is a bit wider, because the grasshopper computational design, okay, it's always related to hyper complexity, to formalism. Okay, so every time people say, okay, grasshoppers, and this is an example, okay, this is just one tool. Grasshopper means crazy stuff, okay, but this is not true. This is not true. It's not always true. It means crazy stuff if the designer wants crazy stuff. If you want to improve, okay, the solar, or I mean the energy, okay, or a building, like Foster and Pattern, I know they use a lot grasshopper to run simulation, okay. Their building don't look really crazy like the Frank Gehry or the Zadig ones, okay. It's a completely different approach, very simple.
As you were saying earlier, it's a way of dealing with complexity, handling complexity.
Yeah.
Yeah.
Well, oh, sorry.
No, please go.
Well, my answer is that this kind of random geometry was an inevitable first stage of new possibilities. I always say, I like to do, I don't know why, music analogy, music metaphors, but imagine when they invented the first electric guitar, probably over the 40s, 1940s, something like that. Of course, probably the first reaction was, oh my God, this produces a lot of noise, that's not sound, probably the first reaction. And it takes time to develop theory of electric guitar and specific sounds. Now we have examples of masterpieces created with electric guitar. But I think that the first reaction was something like that. I mean, it takes time in order to master the complexity, and there is a price to pay, and probably it was this kind of first stage where everyone knows that probably there was a kind of, I don't know to say, overwhelming set of buildings, sculptures, design that was based on formalism, but it always happened in the history of design and architecture. And the last thing is that if you want to really create a free form-finding building, something that really gives answer to structural questions that works, but that has you know, which is created according to environmental analysis and whatever. You cannot do it by hands. You cannot do it without the powerful way that computers have to solve problems. You need to do it. You need to do it computationally. And sometimes it happens to me millions of times when people say, no, computation is not the answer. But the answer is not doing it by hand. That's just a way to give up sometimes. I mean, we need to embrace the technology with a kind of with a mature approach, without any fetishism and without any kind of, you know, love for the. We don't have to use algorithm for the sake of using them, because we like to push boundaries as a, you know, as a mission without any kind of really a real goal. I mean, it's always simple. I mean, we have to embrace technology. I mean, the next step is not algorithms in the trivial way we are using them today, but is AI, is machine learning. There is a really, I mean, promising world of possibilities coming from application in architecture of machine learning, for example. And it's important to say, you don't have to become experts in coding in order to master these things, because as I was saying before, there are new platforms and new interfaces that allows you to use machine learning by dragging and drop a box in your canvas, for example. And then, I mean, there are a lot of things that we should explore in the next future.
Thank you, Arturo, and thanks, Matteo. I think we are approaching the end of the session, and I would like to ask you if you have, to conclude, some advice perhaps for aspiring architects or students in general who may be considering and can't decide whether to learn about computational design and algorithmic thinking and algorithmic tools. What would you tell them? What should I decide and why?
Well, okay, I start.
Yes,
well,
because I'm too young. I'm too young. Advice, sorry.
yeah. Well, well, my advice is not only about, you know, how to become expert. I don't know actually, because I studied by myself, so it's not. I cannot give proper and like advice and answer. But something that I learned is for the young generation, for young students, is trying to become experts into something specific. You know, you should be the best into something very, very niche. And then you have to expand your horizon. So it's important to have a very first stage where you learn how to, not how to use algorithms, but how to use a specific algorithms for doing something very specific. You should be the best into something, and then you have to expand your horizon. And I mean, this is the only advice that I also received from other masters in turn, and I would like to share it with you. But in terms of computational design today, we have, when I started like 12, 13 years ago, there was nothing on YouTube. There were not, you know, webinars or workshops online or something like that. It was really trickier. Now you don't have any excuse. I mean, there is everything out there. But the tricky way, the tricky thing is like creating a kind of theoretical structure, because the opposite is that you have everything to learn from, but it's difficult to create a spine in order to have a structure that helps you in getting better and better.
That's very helpful advice, actually, starting from a specific type of algorithm to learn and then expand your abilities. Would you like to add something, Matteo?
Yeah, make mistakes.
Make mistakes, yeah.
Yes, try and try. Because, I mean, sometimes approaching computational design, but in general, new tools, okay, let's keep calling them new tools, it's frustrating. because you make mistakes. And sometimes your idea is to give up. Okay, don't do that. It takes time. It takes time. It's new. Most of the time, it's new approaches, new way of thinking, and so do it. You do a mistake, next time we'll do that.
Very wise. Thank you, Matteo. Thank you both. Thank you, Matteo. Thank you, Arturo.
Thanks to you. Thanks
Really
to you. Really enjoyed the time with you guys.
Thanks. Mirat, would you like to
Yes. Thank you very much. This was very interesting, and it's one of the things that you keep talking about is that it's not just a tool. I mean, it's not something that you would focus on. You would focus on trying to solve a problem. There's always a theoretical reason behind it. So instead of trying to be a coder, you need to try to be a designer. And so thank you for illustrating that in every which way. That was very great. I want to thank our speakers, Arturo and Matteo, and our guests on Zoom and YouTube. And our guests from the MADI studio, they have zoomed in on one channel. And so this concludes our session. And thank you very much. And of course, thank you, Eleonora, for an amazing discussion. So please join us next session by Mathematics by Design. The talk will be with Daniel Piker and Dr. Yaya Lavapur, and moderated by Anas Leila, who is actually with us in the audience right now. We hope you'll join us then. And thank you, everybody. Thank you very much. And thank you for MADI. We can see you. Bye.
Thanks, everyone.
We can see, can you see them? It's really cool.
Ciao ragazzi.
Yeah. And ciao, I guess, since it's a mostly Italian group.
Yeah.
Yeah.
Thank you guys. This was great.